Hello and welcome back. And in this video, we're going to be taking a look at another very famous interview question that is related to linked list. Add two numbers. So basically, the question states that you're given two non-empty linked lists, and basically those linked lists represent two non-negative integers. The digits are stored in reverse order, and each of the nodes contains a single digit. Now we need to add these two numbers and return them as linked list. Okay, so let's break this question down a bit. So basically, what you've been given are not two numbers, but basically numbers stored in linked list. Now, first hint is that linked list is not empty, so it's not going to be empty, and it's not going to contain any negative integers. So basically, it's only going to be positive integers, and the digits are stored in reverse order. Okay, so that's another important clue, because if you go your math basics and look it up, then what you do basically in math, basically it's like, let's say if you have 1, 1, 1, and you want to add 2, 2, 2, you start from the right and proceed towards the left, right? So you are going to compute 3 first, and then another 3, and then another 3, right? So that's how you compute. Why? Because if, let's say, this number was 9 and this number was 2, that means 9 to 11. So you only take 1 and you move another 1 as a carry forward for the following number. So you can consider it into that calculation. So 2, 2, right? So this is going to be 4, right? And then carry forward goes away unless this number goes more than 10. So you actually continue forward. So this is exactly the reason why we've been given a linked list in reverse order, because this is going backward, and linked list only goes one direction, right? So because this is a single linked list, so the way numbers are given is you have 9, then 1, then 1 already. Now, if you were given 119, then as a linked list, then you would actually reverse it in order to make your calculation better, because another reason is, let's say if this number was 9, right, then your carry forward actually, so your carry forward is going to be 9 to 11, and you take 1 and take that 1 carry forward and put it here, right? So there's nothing that you're going to add, so you're simply going to put 1 here, right? So that's going to be your summation. Now imagine same in the flip order. So when you have another, so for the result, the way your linked list is going to be built is going to be 1. Once again, going from the back, and then you're going to have 4, and then you're going to have 1, and then you're going to have that carry forward that you're going to put as 1 at the end of the node, the last node, right? So that's how you're gonna read it. So that's why your linked list is given in reverse order already to you, okay? Because it's easier to insert that new element and put the carry forward value in there. Now each node contains single digit. That's actually obvious. So basically, you have just a node that has single digit and pointer to the next element, where the next digit you're gonna find. Okay. So yeah. So basically, that's the question. Let's take a look at the example. So we have 2, 4, 3, and 5, 6, 4. Basically, is 342 written in reverse, and 465 written in reverse in this, right? And your output becomes 708, basically for 8 of 7. If you take a look at another example, it's 7, 5, 9, 4, 6, which is written in reverse for 6, 4, 9, 5, 7, and adding 48 into it. Okay, so those are the examples, and Now, I'd like to request to pause the video and basically try to come up with your own algorithm, and then we'll see what we've got waiting for you as a solution. So pause the video here. All right, so hope that went well, and let's take a look at the solution that we have got for you. So let's go ahead and jump into the REPL, and I'm going to remove this. I hope this example actually helped you. Okay, so we have this function add two numbers that takes two numbers. Okay, so first thing we're going to do is we're going to cache them into a local variable so we can modify that. Okay, now we need few other variables. So we need a variable for carry forward, and we need a variable for our result that we're gonna actually move with the linked list that we can actually keep our results in, and we're gonna initialize initially with -1 just to get started, and then you're gonna have head, which is going to point to result. Okay, you're going to return head dot next because we don't want that -1 to be returned. That's just there for, like, it's called a Sentinel node, and it's just for calculations. When you don't have full-fledged list, you can actually start your list with this node and continue forward. This becomes your root, and then eventually you replace your root with the first element in the linked list. All right. So with that said, let's go ahead and put a while loop, and we're gonna put while loop for L1 and say check if L1 is not nil or L2 is not nil. Okay. So run this loop till the time these two become nil. And we're going to check if L1 is not nil. So first thing we're going to do is we're going to take whatever value carry has, and we're going to add L1's data value into that. And we're going to move our L1 to next pointer. Okay. Now we're going to do the similar operation for L2. So if L2 is not nil, then we want to take carry and add L2 dot data into that, and L2 is equal to L2 dot next, right? Okay, so once we have done that, now we are ready. Our carry has the summation for L1 and L2 when they both have value, or only for L1 when L2 is nil, or only for L2 when L1 is nil. So we have all those values and carry forwards. So what we're going to do is basically take our result, and we're going to say result.next is equal to node, and we want to take the modulus for our carry. Okay. Modulus of 10. Okay, mod of 10. Okay, so let me show you what mod of 10 actually is. So, for example, let's say if you have a number, let's say print 1, 2, 3 mod 10. All right, let's take a look at what we get here. So we get 3. Now you can see it's the very last number in the in your digit, right? So very last number. Now there is a technique where you can apply. You can compute the next last digit of this number. So you can simply say, for example, let's say if we put this in a variable, and we say num, first print num mod 3, right? And then print num divided by 10 mod 10, sorry. Okay, so you get 3, 2. And if you repeat this operation one more time, so if you say either 100 or 10 times 10, right, it doesn't make any difference. Both of them are true. So if you say 10 times 10, you can print each individual digits in your number by applying this technique where you divide the number by 10 and then take its modulus. So you actually get 1, 2, 3 back. Okay, so we're going to apply the same technique to get the last digit in our carry. Okay, so if you remember, if 9 plus 2 is 11, you only consider, or 9 plus 3, let's take, right, is 12, you only take the last digit and you put that in your calculation and then move 1 to the carry forward, right? So that's what we are doing. We are taking this 2 value and putting it into the node and taking 1 and putting it into the carry. So let's do that. So carry divided by 10, right? So that gets us the carry forward. And then we simply say result is equal to result dot next. Okay. Now this gives us basically all the calculations, but what's going to happen for those cases, if you recall, let me do that again, 9, 9, and 9, and you have 2, 2, 2. Okay, so your calculation becomes basically 11, and then you get 11 here, so you get 12, and you get 1 carry forward, and then you get 12, so you get 1 carry forward. Now there is that 1 that's here as a carry forward, right? So that is remaining. It's not even considered yet. So what we're going to do, we're going to say if carry is greater than 0, right? Then we simply say result dot next is equal to node with data carry. Okay, and then we return our head. So what we are doing is we are putting that 1 here. Okay. Excuse me. So now with that, our function to compute addition of 2 numbers is ready. So let's go ahead and test it out. So we're gonna get num1 and node data, and let's say 7 num1 dot next is node data 5. Let's copy that, and I'm going to say dot next, and once again here it's going to be 9. Let's copy that, and this one is going to be 4, and this one is going to be 6. So we are taking the second example. The reason we are taking second example because these 2 lists are different types. So we'll see how that L1 and L2 being null before 1, so one is going to become null than the other, and then how it's going to play out. So we're going to take num2 node data, and we're going to insert 8, and then num2 dot next is basically 4. Okay, so given these 2 numbers, let's get them to or add 2 numbers, and now this one actually takes 2 numbers, num1 and num2, and returns the head for the calculation for the result, right? So we're going to say current and assign head into it, and we're going to say while current is not equal to nil, print value for current, so current dot data, and current is equal to current dot next. There you go. Okay, so let's go ahead and run this and test it out, and we can basically say this one is already let, so I think this head is talking about. Yeah, so there we go. So we have 5, 0, 0, 5, 6. So if you take a look, it's 5, 0, 0, 5, 6. All right. So that's actually a solution for add 2 numbers that are given in the linked list. So So hope you guys enjoyed this, and thanks again for watching. I will see you guys in the next video.